So we have notes on how to solve for missing sides in right triangles using trigonometry. Now this process will only work for right triangles. You'll learn other kinds of triangles next year, and it's always going to be using right triangle, and it's going to be relative to the acute angle given. We're going to label the sides relative to the acute angle that they're talking about. Sometimes this will be a theta, but for this, I'm always going to give you the angle, and we're going to solve for a missing side. Okay? So we have a 27-degree angle. That's what I'm going to focus on. And I'm going to label these sides opposite, the leg that's opposite. This is the leg that's adjacent or touching. And the hypotenuse is always across from the right angle. So you could start with that one. Okay, after that, after we label, we should choose the best trig ratio to use, the best trig function to use to solve the problem the most efficiently. Now you could use other ones, but the best one will solve it in one step. Okay. So we write out the acronym SOHCAHTOA, and we look at the two sides that have numbers or variables on them. So that's opposite and hypotenuse. Now, adjacent has nothing. So cosine uses adjacent and hypotenuse, so get rid of it. Tangent uses opposite and adjacent, so get rid of it. Sine uses opposite and hypotenuse. So that's the one we're going to want to use. Okay, so that's the two sides that sine wants to work with. Okay, opposite and hypotenuse. So now we're going to show the mechanics after we make our choice of sine to solve for sides. Okay, so it's going to be sine of 27 degrees. Now that's a function in your calculator. You're going to type in 27 in sine, and it's going to punch out the decimal value. Now, what that's really doing is it's telling us what we can expect the ratio of the opposite side to the hypotenuse to be. Okay. Now, the calculator tells me that sine of 27 is 0.4540. What that means is I can expect opposite over hypotenuse to be 0.4540 over 1. Now, the reason we're doing this, now we're going to sub in this triangle's opposite is x, and this triangle's hypotenuse is going to be 22. Now, what we're saying with trigonometry is all right triangles with a 27-degree acute angle are similar. So in similar triangles, remember, we set up proportions to solve for missing sides. So that's why this process is not much different than what we've already studied. That's why I like doing it this way. So for now, until you become experts at it, think of it this way and use the same mechanics that I do. Okay, now we're just cross multiplying and solving. I'm going to round everything to 2 places because that's what our homework is. Okay, next one. So same process. We're going to look at the 38-degree angle and label the sides relative to that angle. Now, because the 38's here, that's opposite. And touching is adjacent right there for x. Hypotenuse is across from the right angle, so that doesn't matter what which acute angle we're talking about. All right, then we write our acronym to make our choice for the best trig function to use. Now, it happens to be tangent because we have a number for opposite, we have a variable for adjacent, we have nothing for hypotenuse. Tangent uses opposite and adjacent. Again, mechanics, we have the tangent function of 38 degrees. And I jumped the gun a little bit. I should be saying opposite over adjacent here, so I erased it. Okay, so tangent wants opposite over adjacent. 38 degrees. All right, the ratio of the opposite to the adjacent will be 0.7813 in your calculator. Well, just put it over 1, so it's the same as this ratio. Now, a similar triangle with a right angle, 38 degree, has 14 for opposite and x for adjacent. Now we're going to cross multiply. And this time, instead of multiplying, we're going to have to divide to get our answer. So 14 divided by 0.7813. It's going to be half and half. All right, next one is a special right triangle, but we're going to use trig to solve it to show you that you don't have to memorize the trig ratios, or I'm sorry, the special right triangles. If you did know this one, the hypotenuse is double the smallest side. So it's 24 if you remember the 30, 60, 90 right triangle. But we're not going to do it that way. We're going to use trig. So there's my acronym, SOHCAHTOA. I'm circling cosine because adjacent has a number and hypotenuse has a variable. So mechanics, the cosine function, when we type in 60 degrees, just type in 60 and make sure it's in degree mode, is adjacent over hypotenuse. Cos of 60 is 0.5. This right triangle's adjacent is 12, hypotenuse is x. We're going to have to divide this time, so 24. And last one, label relative to the 35. There's opposite, hypotenuse, adjacent. Now remember, the opposite and the adjacent have to be the legs. If you want to make sure you don't mess up, you want to label the hypotenuse first. Some people do it that way. That's a good idea. Writing my acronym again, circling cosine because adjacent and hypotenuse are involved. So now my mechanics, I put cosine function 35 in the parentheses. I'm expecting it to be the ratio of the adjacent to the hypotenuse. The decimal comes out 0.8192. So 8192 to 1 is what we can expect this similar triangle to be, which is going to be x over 24, cross multiply, and solve. So there's a demonstration on a few different 4 problems for solving for a missing side using trigonometry. Hopefully that was helpful, and that should be used for our 7.40 assignment, pages 17 to 19. Thanks so much.